All right, what if it says factor and it's not doesn't look like ax squared plus bx plus c. It's only x squared, yeah, x squared, and then just a c here. Okay, c is always a constant. There's no just x's here. There's no bx. So here's what you have to think about. This might be what we call a difference of two squares. See, difference means subtract. Yes, it is a difference. And are these two things squares? Is this a square? Well, obviously, it's x squared. Yes, that's a square. Is this a square? Is 49 a square? Actually, it is. It is 7 squared. So, this is a difference of, this is a square and this is a square. Difference of two squared. So, I like to rewrite it. X squared minus 7 squared. When you have a difference of two squares, all you have to do, basically, is just say, well, here's a pattern. If you have a squared minus b squared, we'll just say a and b could be anything. In this case, it's x and 7, right? It is a minus b times a plus b. Okay? So you need to figure out what is a and b. Okay, in this case, what's a? It's a squared, so what's a? A is just x, right? A squared. So a is x minus, what's b in our case? Well, it's b squared. So what is b? So there's b, and that's squared. So just b. Here's b. All right, so b is 7. So x is a, and 7 is b. So plug them in. X minus 7 times x plus 7. All right, so x minus 7, x plus 7. Notice it's factored, okay? What does that mean? I don't know if I've said this in the earlier ones. I'm kind of jumping all around. If I said factor 6 for me, well, that's 3 times 2, right? There's two factors that multiply together to give me 6. If I said factor this, what are some things that multiply together to give me this? Well, this times this should give me this. You can multiply real quick. That'd be x squared, x times x, FOIL. X times 7 is plus 7x. Negative 7 times x is negative 7x. And lastly, negative 7 times positive 7 is negative 49. Look what happens. This is 0. X squared minus 49 is left. So when I multiply these two, this is my answer. So I am correct. I did factor this to here. So factored form is right there. I broke it down to two factors. Okay? So whenever you see something with two terms, 1, 2, you look to see, is it a difference of squares? Maybe it is, and it can factor here. What about the next one? The next one is ax, or x squared plus bx plus c. If you want to, look at it like this. What are factors of c that add up to b? Factors of c, 6 and 6. Does it add up to b? Yes, it does. So these lead me to my factors of x plus 6. No, not x, because we're using d. So d plus 6 and d, and the other one is also plus 6. But that's not your best answer. If you wrote d plus 6, I might take a point off. This is better known as d plus 6 squared, right? Same thing. So just write it squared. That's a nice answer right there. All right. So this is actually right here a perfect. This right here is a square. Right there it is. Okay. Just like I said, 9. 9 is a square. It's 3 squared. So 9 is a square. Correct? It's the same thing. This thing is something squared. So this guy right here is a square. It's a perfect square trinomial, we call it. Okay? So perfect square trinomial. Know those words right there. It's a trinomial which makes a perfect square. D plus 6 squared. All right, last one on this part. Z squared minus 26z plus 169. Same thing. What are factors of this that add up to this? Well, you might have to play with this one for a while, but it's negative 13 and negative 13 make this if you multiply it, and if you add them it makes this. So we're going to get our two factors out of this, z minus 13, z minus 13, but once again you can't write that, you want to put them together, z minus 13 squared. And once again this is also a square because this, if you factor it, is a square, perfect square. Just like 9, if you factor it, is 3 squared. Okay, this is a perfect square trinomial. Alright, so a little bit of special patterns here just to think about.